Hi, this is a little video on dividing radical expressions. So remember that there's a couple rules when we divide. We cannot leave a radical in the denominator of a fraction, so we have to get it out. We also cannot leave a fraction under a radical. Okay, so the first one's fairly simple. Let's remember that we could go both directions, that we can break them apart. I can break this into numerator, square root of numerator over square root of denominator, or I can put them back together if I need to, whatever's handy. So in this case, the square root of 81 over the square root of x squared is an easy one because I can't leave this radical in the denominator of this fraction, but this is a perfect square, isn't it? The square root of x squared is just a simple x, and the square root of 81 is a 9. I can leave a radical in the numerator, that's okay, but I didn't have to. So this is just a simple 9 over x. My second one, I've got 6 over the square root of 2a. Right away, it's illegal. It's not considered a convention to leave a radical in the denominator of a fraction. So we're going to use something called the big fat 1 to get it out. There is nothing that I can multiply this whole thing by except for 1 to leave its value the same. So what we're going to do is we're going to multiply it by what I call the big fat 1. Okay. And we're going to change the appearance of this without changing its value, because multiplying by anything other than 1 will change the value, and I can't do that. I can't just willy-nilly change the value of the number I'm trying to simplify. Okay, so I call this the big fat 1. I'm going to multiply it by the denominator, the square root, because when I multiply the square root of something by itself, I should get that something. In other words, if I multiply the denominator here, the square root of 2a by itself, the square root of 2a, by definition, shouldn't I get 2a? That's what a square root is. It's something that when multiplied by itself gives me that thing. So I can't just multiply by, 1 over root 2a, because that will change the value of this. But if I put this as the square root of 2a over itself, that is really just a big fat 1. And then I multiply the numerator by the square root of 2a. So 6 times the square root of 2a. And then I look if there's any other place that I can simplify. I can only simplify numbers on the outside of the radical or inside the radical, where I have terms that are the same inside the radical. But the 6 and the 2 can be, that is a 3 over a 1, isn't it? So I'm left with 3 times the square root of 2a over what we call a rational a. Okay, and this process of taking it from under a radical to being outside a radical is called rationalizing the denominator. And the way that we do it is we use the big fat 1. We multiply it by this expression over itself. Okay, then the last one is different than this one, because this is just the whole term is under the radical. In this, it's part of an expression. It's a binomial. It's got a plus or minus in it. So 5 minus the square root of 3. I cannot just multiply this by a big fat 1 in the form of root 3 over root 3. That won't work because of this 5. So I want to teach you what conjugates are. Conjugates are opposites added and subtracted in the same direction. So a plus b, a minus b. These are what, like a married couple, a plus b and a minus b, where they are conjugates of each other. A plus b is the conjugate of a minus b. A minus b is the conjugate of a plus b. Think of them as partners with opposite signs. So look what happens whenever we multiply conjugates together. First terms, we get a squared. Outside terms, we get a times negative b, or negative ab. Inside terms, we get positive b times a, or positive ab. And last terms, b times negative b, we get negative b squared. No matter what, when conjugates are multiplied together, we always end up with first term squared minus last term squared. So the a squared minus the b squared, because these two middle values are always opposites of each other and they cancel each other out. So I always have first term squared minus second term squared. So I'm going to use the conjugate of 5 minus root 3 and multiply it because by 5 plus root 3. This is going to be multiplied by its conjugate, 5 plus root 3, because I know that this radical will go away because it's going to be squared. I'm going to end up with 5 squared minus root 3 squared. So I'm going to think of this like a binomial, and then this other binomial, its conjugate is 5 plus root 3. So that's in the denominator of a fraction. Again, though, I only can multiply something by 1. So because I don't want to change that expression. So this is going to be multiplied by 5 plus root 3 in the numerator. And there's my big fat 1. Okay, and so what do we get? Well, I'm going to get 5 squared, and I know my middle terms are going to go away because, right, I'm going to get 5 squared, 5 times 5, plus 5 root 3, minus 5 root 3, and then minus root 3 squared. So 5 squared is 25, and these two cancel each other out. And root 3, when I square it, the square root of 3 times the square root of 3 is by definition 3, so minus 3. And then in the numerator, I'm going to distribute this. I'm going to get 2 times 5, which is 10, and 2 times root 3, so plus 2 root 3. Okay, so 10 plus 2 root 3, okay, over 25 minus 3 is 22. And then I look and see if I have a common factor in this triangle here of the rational numbers, the ones that are outside of under the radical. We call these rational. Those are radicals under there. And I've got a 10, a 2, and a 2, and the common factor is a 2. So if I divide out by 2 on all three of those, I'm going to get a 5 plus a 1 root 3 all over dividing by 2, 11. So that's my final answer, 5 plus the square root of 3 over 11. I've rationalized the denominator. Okay, that's it.